Hello and welcome back to our last tutorial class on control system ESA 251. Okay, for this tutorial class, I'm going to cover two chapters. Okay, the first one, which you can refer to lecture week 13 in the slides. It's basically on chapter 5 in the book text, which is about reduction of multiple subsystems. So all around us, it's basically a multiple of subsystems. So this is an example of a multiple subsystem. So once you are given this type of problem or this subsystem, you need to make it to a simple single block diagram like this one. Okay, so from here we need to get this one. So basically there are a few steps. Okay, the first one is, okay, if you could see here, there's controller and there's plant. So it's basically you just apply the multiplication. So G1 times with G2. So transfer function of G1 and transfer function of G2, and you get this block diagram. And then same goes to H1 and H2, because it is sitting beside each other. It is cascaded blocks, so you just can multiply between both of those blocks. So ending up, you will get something sort of like this. So this is your G and this is your H after the multiplication. Okay, the next step is that you have to eliminate a feedback loop. So if you could see here, it is a feedback form. Okay, so we want to make it as our objective is to make it as a single block diagram. So we need to simplify this part. Okay, there are two conditions where H is another transfer function. So in this case, you simply apply this type of formula. Okay, if this one is G and this one is H. But let's say it's a unity feedback system, which is H is actually equals to 1. So you basically just need to apply this type of problem. So it doesn't make any difference that much once you remember this one. So this one is just the same, because if it's 1, this one is 1. Okay, so this is how you eliminate a feedback loop. Hence you're ending up having this type of a single block diagram. So this is your main objective. You need to get this before you do a certain analysis of a system. Okay, next you can do some examples. Okay, and that's in book text. They are given the solution as well. Okay, apart from that, another chapter which is you can refer to lecture week 12 to 13, which is chapter 6 on stability. So this one, you can do this kind of problem where you need to find the range of gain k. So k can be any integer. Okay, and once you input, once you choose a certain number of that integer, the system can be stable or it can be unstable, and it can be marginally stable. So if you want to find out these cases, stable, unstable, and marginally stable, basically you have to do that RH criterion. So what is that? You have to understand how to generate a basic root table. So basically, once you have this this system, make sure you make it as a single system or single block diagram, just like this one. Okay, you ended up like this, and then from there you have this transfer function. So the first two lines here is actually from this characteristic equation, which is this denominator of the transfer function. So make sure it's in order: S4, S3, S2, S1, and S0. And then from there you look at the coefficient. So the coefficient of S4 it goes here. The highest power is 4, so you start with S4, S3, S2, S1, and S0. Okay, the first two lines is actually the coefficient of each of these. So this is A4, A3. You go down here, up here, down here, up again, and down. Okay, so those are the things that you have to know how to generate a root table. And from there, you just basically it's just a multiplication to find those B, B2, C1, and D1. So once you do lots of exercise, you will get used to it. And if you do that problem, okay, I will give this lecture note, and you can see what are the solutions to find that problem. Okay, so basically you just need to find the transfer function and then generate that root table, and from there you can determine the K. Okay, so it can be stable, unstable, and marginally stable. So that's all for today, class. I hope you have those revision for your examination, and all the best. Thank you.